Welcome everyone to 14.4 perpendicular lines. We are talking about perpendicular lines. What perpendicular lines means, right? If these two lines, line L and line N, are perpendicular, what that means is that it's just that little box. Remember that little box means that it's 90 degrees, okay? That means that it's perpendicular, where they intersect at a 90-degree angle. So some definitions here are perpendicular lines, right? And what that means is two lines that intersect at a 90-degree angle. Okay? Pretty simple. What this section goes over is what a perpendicular bisector. So what is a bisector? Okay? A bisector, if you guys think about the prefix bi, right? Bicycle comes to mind. So a bicycle is a bicycle because it has two wheels, right? Like a tricycle is a tricycle because it has three wheels. A unicycle has one wheel, so it's uni. A bicycle has two wheels. So a bisector, what that means is something, it can be a point, or it could be a ray, not a point. A ray or line or segment, okay? Ray, line, or segment that cuts the segment in half, okay? So all you have to remember is it cuts it in half, okay? Whatever it may be a line, a ray, or a segment that cuts the segment or the other segment in half. So let's say that line L is the bisector of line N, okay? Then that means that if this was a segment, right, a line with two endpoints, that means that this part here, let's label these points A, this point is B, and that point is C, that AB is equal or congruent to CB, okay? And these two tick marks just means that they are equal, okay? So if line L is now in this case, is the perpendicular bisector of this segment AC, that means that it's perpendicular, and that means that it's that this line cuts this segment in half. All right, that's the big idea. So let's see how we use this. There is a theorem called the perpendicular bisector theorem, okay? And the perpendicular bisector theorem is if a point lies on the perpendicular bisector of a segment, I'm going to pause right there because it's an if a point lies on the perpendicular bisector of a segment. Okay, if this happens, then this will happen, right? If I study for a test, then I will get a good grade, right? So you have to study first. The if statement has to happen first. Okay, so that's why I stopped right there. If a point lies on the perpendicular bisector of a segment. So let's say I have these two segments here, okay? And let's say I have point P here, which lies on this red line is the perpendicular bisector of this green segment here, okay? So if this happens, okay, then it is equidistant. Equidistant. Equidistant just means equal in distance, okay, from the endpoints of the segment. So if I go ahead and I draw two segments here and here that connects the two endpoints, that means that this is also equal to this, okay? So if I have point P, which lies on the perpendicular bisector, then I know I would have an isosceles triangle, or this is an isosceles triangle because two sides are equal, then it is equal in distance to the endpoints of that segment. Okay? So that being said, let's do an example, a quick one, pretty simple, right here. Use the diagram, this diagram here, to show or shown BD, so this vertical segment here is the perpendicular bisector of AC. Okay? Notice that point B is on the perpendicular bisector, right, of AC, and point D is on the perpendicular bisector of AC. So if point D is on the perpendicular bisector, isn't that picture right there? If I cover it up, let's say here, if I cover this up, right, isn't that picture the same thing that I drew here? Right? That picture right there, I'll show it to you guys again. This picture right here, right? I just covered up point B, right? Is the same picture as this picture here. Okay. So point D lies on the perpendicular bisector of AC, which means AD, okay, is equal or is congruent to CD, is equal distant from the endpoints of that segment. Okay. Again here, if I cover this up with my thumb, point B, which is on the perpendicular bisector of AC, then AB is going to be equal to BC. Okay, so I can just draw these little tick marks here and here. Okay. All right, so if you look at number 4, suppose that ED is 16, DA is 20. Well, if DA is 20, I know DC it has to be 20 as well. And that's what we have to find. Okay. ED is thrown in there just to throw you off. Okay. And you will figure out that ED is there if you want to figure out what AE is. And we'll do that in a little bit. Okay. So look at number 5. EC is 15. So I know EA is 15. That doesn't really matter for this question, but I'm just letting you know. BA is 25. So I know BC is also 25, and that's my answer. So that's 25, and DC is 20. Okay, so that's just a quick example of what we're gonna do today in our assignment. Okay, so here is that theorem again, if you guys were taking notes. All right. So if that's the case, then the converse of it, meaning I'm gonna just get my if-then statement and then flip them. So here, the converse of this perpendicular bisector theorem is if a point is equidistant from the endpoints of the segment. Hold up. Let's go back to the perpendicular bisector theorem. Okay. This is the perpendicular bisector theorem. And let's go to that then statement. it is equidistant from the endpoints of the segment. Notice that the if statement for my converse is the same thing as the then statement for my theorem itself. Okay, that's what a converse is. It takes the then statement here, puts it at the if statement for the converse, and then my then statement, then it lies on the perpendicular bisector of the segment, is actually my if statement here. If a point lies on the perpendicular bisector of a segment. Okay? So this really means basically the flip version of the perpendicular bisector itself. So I have if a point lies, or if a point is equidistant from the endpoints of the segment. So I know this, right? I know that this segment is equal in distance to this segment, okay? Then it lies on the perpendicular bisector of that segment. So then if I draw a vertical segment from that point down, right? I know that this is perpendicular and I know that they are equal. Okay? So whenever you see a perpendicular bisector or a triangle like this, right? An isosceles triangle, then you know those two things, okay? Then they're equal in distance. Okay, you either know this one is equal to this one because of the perpendicular bisector theorem, or you know that these two guys are equal in green because of the converse of the perpendicular bisector theorem. All right? So in this case here, number 7, AD is 10 inches long. Okay, 10 inches. BD is 6 inches. Notice that B or AD is equal in distance to CD, right? So that's 10 inches long as well, right? Because of these tick marks here. If that's the case, then I know AB is equal to CB. Yeah, I know that these two segments are going to be equal. Okay? So if I cover this up right here, I have, or if I cover this up, because then this already has the 90-degree angle, it's a right triangle, right? And what do we know about right triangles and their sides? Well, they follow a strict formula. A squared plus B squared equals C squared. Okay? Remember, C is always going to be your longest side. That's always opposite the 90-degree angle. And A and B, it doesn't really matter. I'm going to label this as X so that we can just solve for X. If this is X, then this is also X, right? Because they're equal. Okay, so X squared plus 6 squared equals 10 squared. Okay? So X squared plus 36 equals 100. Subtracting 36 from both sides, I have X squared equals 64, right? 100 minus 36 is 64. If I square root those two, X is going to equal, I'm going to put the plus or minus. Square root of 64 is 8. But since we are talking about a physical thing, a segment of a triangle, it has to be the positive version. Okay, I put the plus or minus there because we know if we take the square root and we're solving for X, it can be plus or minus. Okay, so X equals 8. So then this is also 8. And I'm ready for the question itself because I figured everything out, right? I know that that's 8, that's 8, that's 6, that's 10, and that's 10. Find the length of AC. AC is going to be 8 plus 8, which is 16. Okay, so that's 16 inches. All right. Okay, let's do another example here. It says, number 9, given that B is parallel to D, and I'm going to make these tick marks. Remember these tick marks in our parallel lines? These arrow marks, I mean. Yeah, signifying that they are equal to each other or they are parallel to each other. Okay. C is also, line C is also parallel to line D. So I have two sets of parallel lines, right? Measure of angle 1 is 50. Measure of angle 5 is 90. Okay. Now, I'm not even going to look at what I have to figure out. Okay. I'm going to imagine that this is not even there. All right. Because what I want you to do is try and figure out everything else. Okay. Without even figuring out what measure of angle 4 is. Okay. That's what we're going to end up answering. But what I want you guys to practice and what I need you guys to practice is trying to figure everything out. Because if you guys can figure everything out, doesn't matter what the question is asking, you guys can answer it. Okay? So, let's see. I'm going to treat line A as my transversal, right? If angle 1 is 50, I know angle 2 must also be 50, right? Because they are corresponding angles. Okay? If angle 5, wait, hold up. Angle 3 is also 50 because they're vertical. Angle 3 and angle 2 are vertical angles, right? Well, if angle 5 is 90, I know 2 plus 6 must also be 90, right? Because they're linear pairs, right? If angle 2 plus 6 is 90 and angle 2 is 50, this angle, angle 6, must be 40. Yeah? Makes sense because it has to be equal 90. And angle 6 and angle 4 are vertical angles. So that angle is also 40 degrees. Okay? So notice that I've labeled all of the angles that's numbered, right? You can even take it a step further and say, hey, look, this angle here is 40 degrees. This angle here is 40 degrees. This angle here is 50 degrees. These are both 90. Okay. And this is 90 as well. Okay, so I've labeled all the angles. All right. So find measure of angle 4. It's 40 degrees. And I'm asking you to do this right now on your homework or on your assignment because come assessment time, it doesn't matter what angle I give you or what angle I'm asking you to find. You're able to figure it out. All right. And that is the lesson for today, class. Hopefully it made sense. And I will see you on the next video.